Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the sequence of events that took place to form planet Earth. So the story begins, as really all stories do, with the Big Bang, around 13.7 billion years ago. And shortly after the Big Bang, hydrogen and helium atoms formed, and those hydrogen and helium atoms were stuff from which early galaxies were forming around 10 billion years ago. Now, some of those early stars didn't last. They went supernova, which means they exploded, and the energy of that explosion was enough to synthesize heavier elements. It's from the remnants of one of those explosions that our solar system began to form. This is a solar nebula, and it's beginning to contract thanks to the force of gravity around 4.7 billion years ago. Gravity causes it to compact and spin into this sort of pancake-like shape. The material in the middle of this protoplanetary disk is igniting as a new sun, and that new sun is surrounded by this disk of dust and gas, some of which condenses into planets. As the Earth forms, it's continually being bombarded by new material. So basically, this is the stuff that the planet's made from, but it started off smaller and then more and more stuff got added in. Here's an example of one of those collisions that has taken place in the modern day. This is the impact of comet Shoemaker-Levy 9 with Jupiter in 1994. So the comet went and smacked into Jupiter, and in that moment, the solar system lost one extra object, but Jupiter gained a little bit of extra mass. So this has been the overall pattern of the formation of the solar system, is that we go from a larger and larger number of small objects towards a lesser and lesser number of big objects. The decay of radioactive elements released a tremendous amount of heat in addition to those meteorite impacts, and so that produced a magma ocean. Early in Earth history, when meteorites were impacting the Earth and splashing down in the magma ocean, you can see some of the early primordial crust here beginning to form as basically like little solidified plates on top of a lava lake. That magma ocean allowed differentiation of the Earth, which means that the heavier stuff sank to the middle and the lighter stuff rose to the outside. This sort of differentiation also happened on other planets in the solar system. Even some asteroids underwent some level of chemical differentiation, and we know that because of their compositions in the form of meteorites. The children's story, The Little Prince, has the title character traveling around to some objects that appear for all the world to be planetesimals. And one of the things that I like about this image is that this planetesimal is showing clear evidence of differentiation and outgassing, as there's a little volcano here spewing out gases. That's a process that would have taken place on the early Earth as well. Around 4.6 billion years ago, another planetesimal, smaller than the Earth, smacked into the Earth. And we know that this must have happened after differentiation, because the material that it blasted off was not the same as the bulk composition of the Earth, but it was pretty much the composition of the Earth's mantle. That material coalesced around the Earth in a ring and accreted to form the Moon. So the Moon basically has the same composition as Earth's mantle thanks to that glancing collision post-differentiation. Finally, the Earth begins to outgas, and that outgassing produces the primitive atmosphere and the primitive ocean. Thanks very much for your attention. This has been another Smart Figure.